All right, so we're on page 13. We're just going to continue where we left off. Should be writing this all down. And I already made a lesson before this, so if you missed it, all the way up to here is already done. Okay, so again, we went back to a two Venn diagram set. Information was given. This is a completely filled in Venn diagram. And so we used it to also show that the principle of inclusion and exclusion, that equation, that formula that I gave you, if you use it correctly, you actually end up getting the exact same information here. And just to be sure, when you're trying to find the union, if you were to just add 6 and 5, right, that would get you 11. And that's not right because you're double counting. Like for set W, you're counting these three already. And then if you just add the 5, you would be double counting, right? So that's why we need to subtract the overlap when we're using the formula, especially if it's a joint set, like this is a joint set, right? So here we go. What did we find with the 8 is students, number of students that is, that walk or bike, right? So that's in this case, and I'm using walking and biking, right, because I want to kind of keep it the same for this section, but that could very much vary depending on the situation. All right, so let's fill in all of these, and I might also add what they mean in the word problem, right, that we're trying to solve or that we're considering. Okay, so the U is, in this case, it's still 10. It's all students in a particular class. It could be students in a school, in a class. It could be just tenants that are living at an apartment building. It could be the people at a mall, whatever you, right? It could be the number, all the even numbers, right? That could be a universal set, so that always varies, okay? The number of students that only walk, in this case, would be 3. Students that only walk. This is students that are only biking, right? So only walking would only be this, only biking, right, would be that. So that's 2, right? Students that only bike. Okay, emphasis on the only because you want nothing from the other set as part of it. Okay, and then let me zoom out because I'd like you to see the Venn diagram as I'm filling this out. So the number of elements or the number of students that are not walking, remember I told you to take the universal, take all the students that walk, and we have 4. Okay, so if you cover up walking, you end up including the outliers, right? All of those would be considered non-walkers, right? So students that don't walk. That's all we know when it's stated like that. State the intersection of W and B. Okay, and that is not asking for the number, but actually the elements that are in there. So I'm just going to make sure I do this in alphabetical. Remember, alphabetical, arranged, and you cannot have repeats. That's key for a set. So Jenna and Xenia. Okay, so that would be 3, of course, and we have that. Next, use set notation to write set W. So set W, we have Anna. So I'm just going to take everybody that is in W, okay? So when you're thinking W, actually think of the whole circle, right? So it's all 6 of them, okay? So Anna, Biff, Chip, Damien, Jenna, and Sanya. Okay, so you've got, oh, is that 6? Yeah, 6. Just double checking, 6 in there. And then I'm asking, is set B a subset of W? Another way of looking at it is, are all the elements that you use to create B, right, also found in W, right? It's almost like, is B an offspring of W in a sense, right? And you look at B, and it's clearly not, right? If B had been inside, like a subset like that, right, where it's nested inside the other, then it's true. But B clearly has two that are not in W, in walking, that are non-walkers. So no, right? That's false. Set B has two elements, and the way you answer this can vary, right? Has two elements that are not in W, okay? Or you can also say not all elements in B are also in W. That's another way of saying the exact same thing, okay? I will say this example, Joel, right? That's one example. It's almost like you find one element that is not in the other, and basically case closed, right? Next, it's still a joint set, but this is actually where we have subsets. Okay, so I will actually put down subsets in particular. So we're going to use the same reasoning as before, so I will maybe go a little bit faster here, perhaps. Okay, so we're still the same set, but to find, if you want to use pi, right, to ask you to use that principle to answer, right, then you need to do that, but you can use the Venn diagram to as a guide. So there are still 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That doesn't change. For W, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So there's 10, no outliers. I don't know if you noticed that, right? B has 4, okay? And so let's start. So for this formula, notice that this is saying the number of students that walk or bike, right? So that would be like this. You take the number of elements in W, you add the number of elements in B, and of course this is wrong, right? We know it's not 14. Why? Because there is an overlap. In this case, this would be the one that both of them share. Okay, so you'd have to go -4. Right, just subtracting the overlap, and that's how you use the property. So basically these two cancel out, and you end up with 10, which is exactly what in this case it is, right? Because I told you another way of coming up with the union is to take, right, if you go the universal set minus any outliers, okay? And so 10 minus 0 is 10. Okay, so that's another way of getting there. Remember that to refer to outliers when there are only two sets is you take the union and you say, I don't want that. I don't want that union, and that would be everything outside. So this is, in this case, an empty set, right? Null set. So keep that in mind. In this case, there are no outliers. And I could actually write this as n of this notation, but I feel like it gets a little bit too messy, and I think you understand what's happening. And so let's do the same thing. We're going to now find the intersection between them using pi. So I use this one every time, right? And so it's n of the first one plus n of the second one minus the intersection of the two, right? So then it's going down, okay? And we have that to start. In this case, I want to find this, right? They're asking me to find that. Oh, and just as a curveball, B intersects W is the same thing as W intersects B, okay? It's exactly the same. Don't let that throw you off. I did that on purpose, okay? We're talking about the intersection of the two, so it doesn't matter which one you write first. So let's pretend like we know this already. We know from before, just by looking at the diagram, that this is 10. This, by looking at the diagram, is 10. This, by looking at the diagram, is 4. Minus, this is going to be our unknown. This is what they're now asking me for. And I just bring over the numbers. So 10 comes over subtracting. 4 comes over the equal sign, subtracting, right? You insert the equal sign. So it's almost like these two are coming over and they change their sign. You're left with negative x. This, of course, gets you to 0, so it's negative 4 is equal to negative x. Divide both of them by negative 1. So we know that x is equal to 4, right? The intersection between the two sets happens to be all of the elements that are in B, right? Because this one doesn't go out. It's not like they just have a few that they share. In fact, B shares all of its elements with W. So these are students that bike and walk. So again, universal, only walk. Only walk in this case would be 1, 2, 3, 4, 5, 6. Only bike. In this case, you don't have any that only bike. Because if you were to say only the ones that only bike, then you would be wrong because it's inside of W as well, right? If this circle had gone out like this, outside of W, and you had some elements out here, then you would have something, but in this case, there are none that only bike. Because all Dimitri, right, bikes but also walks, because think of the walking circle. So you kind of have to be careful sometimes. That's why I gave you a bunch of scenarios to start off with. Since all students that bike also walk, subsets. Actually, because of subsets, let's leave it like that, because of them being subset. What are the numbers that are not walking? So take the universal, and you take away the ones that walk, it's 10. So there's actually 0 that are not walking. State the set not W, that is an empty set. Or use the set notation to write set B. So again, we go to B up there and just make sure that you do that in alphabetical order. So that we have Dimitri, Fernando, Jenna, and Joel. Okay. Is W a subset of B? False, right? Not all elements in W are also in B. Example, anybody that's Anna, right? But is B a subset of W? That is true, right? True. True L, all elements in B are also in W. Okay? So that is a classic and so forth. I could ask you, hey, create another subset of W, right? Create a subset of W. You just grab anybody in W and make a new set, and there you go. Okay, now we're gonna switch gears. Okay. Now we're gonna actually use what we've learned here and apply it to a word problem. That's where we're gonna go now. Okay. So go to page 15 here, and we're gonna start with 2 sets. We're gonna end up with 3 sets. Listen carefully. You need to try these. You need to read carefully. You need to highlight and make sure that you're very careful where you put these numbers, because we are going to give you enough information to partially fill in a Venn diagram and then answer the questions that follow. Now, I will from time to time actually with the information given start a Venn diagram right away, because even though it's not asking you to draw a Venn diagram, right? You filling in a diagram will make it a lot easier to answer these questions. Okay, so chances are I might not even read necessarily what's in here. I will just take the information given. It's like, okay, I know this, this, and this. Fill in my Venn diagram as much as I can. Find the rest using pi very often, and then you can actually completely fill in that Venn diagram. So I will have some highlighters. I encourage you to have a red pen or some kind of blue pen, because when I'm adding information, I'm going to use red or blue, whatever works for you. Okay, so let's read this. During the pandemic, a school sent out surveys to 50 homes asking what types of devices were available to students. That right there, 50 homes, is your universal set. That is all. Everything else that follows is drawn from those 50. So the universal set has 50 families, homes in this case in it. So there you go. That's setting the stage. Most often that's going to be the case. 30 students were able to access a tablet T. 25 students were able to access a computer. We're going to use the letter C. It's kind of hinting towards it. And 5 students had access to neither. Okay, so that is often there. When you see something that they didn't have either or, those are your outliers right away. So that we're going to call that outliers. Okay, so basically the number of elements there are in neither set. Okay, and we call that 5. We know that there's 5 homes that didn't have access to either one. 30 students able to access a tablet. I right away know that the number of elements in set T is 30, not 50, sorry. Right, it's 30. And then 25 students were able to access a computer. So you can almost start doing that already before you even start the problem, but you kind of are deciphering, you're trying to see where does this all fit. It does end up asking you to draw a Venn diagram first and foremost. So that's what I will do right away. So I identify, by reading the problem, you identify that there are 2 sets there. And I will draw my box around it. I know that the universal is 50. I know I have 5 outliers, so these numbers represent the number of items that are outside. We don't know the family's names or anything like that, so we can't list them. This is my set T, which I know has 30 families in it, and C has 25 families in it. Now you can tell right away without me even starting that 30 and 25 is 55. That's already more than your universal. On top of that, add the outliers, you're at 60. So that kind of is a dead giveaway that there are families that are going to have both. We're going to have something in here, but we don't know how many yet. Okay. So how do we start this? Okay. In this particular case, you want to focus in on finding the middle piece here. Finding the middle piece. Because it's not given. The question will often say, so and so many families had both, right? But it doesn't say that. So this is the type where I will actually put an X here, right? I'm going to try to figure out how many families are in here. This section is referred to as, what is this? The number of elements of T, and in this case is intersect C, right? And I'm going to call that X. That's the one they want us to find. Or that's what I want to find. That is very important. That is like, if that's not given, that is your go-to. Okay. And I'm going to use pi to figure out this fact. Okay. I'm going to use pi. So use pi to determine intersection. And here you go. What is pi again? The number of elements that are in T or C, right? Number of families that have a tablet or a computer would be taking the number of families that are in T, taking the number of families that are in C, and subtracting the number of families that have both. Okay. And so now you need to fill in what you know for sure. You know that there are 30 families that have a tablet, homes, right? You know that there are 25 families that have a computer. You don't know this. I'm going to call that X. And what about this? Do I know this part? Remember that I always kept on saying that there are two ways to figure that out, right? And this is where that comes in handy. To get this part, we take the universal and we subtract the number of outliers that are in there. Because think about it. If I know that there are 50 families and I subtract 5 from the universal, it leaves me with whatever is in here when I unite them, right? Everything else must be inside these two sets. That's why I'm using this, right? So you have that 45 is equal to 30. Oh, let's already add that up. We can do that, right? Or maybe I'll just leave it. Sorry, I want to be consistent. So then I go 45 minus 30 minus 25 is equal to negative x, and you want x to be negative because this is most likely going to be negative. If your answer is negative at the end, you did something wrong, okay? So this ends up being, this is 55, right, negative. So you end up with negative 10 is equal to negative x. Divide both by negative 1. And so x is equal to 10. What is that saying? What did we just find? We found that intersection. So 10 homes have a tablet and a computer. That's what you just found, right? So mathematically, you did a whole bunch of math. You found 10. What does that mean? What does that represent? This. So now that I have that, it's like a puzzle. Everything will just fall into place. This is the more, like if you find the center, you now work your way out. Okay, so watch this. Now I'm going to figure out how many students or homes, sorry, only had a tablet. Well, you need to take the 30 and subtract the 10 from it, right? And then you're going to get 20, right? Because 30 are including the ones that are also having a computer. But if you only want the ones that have a tablet, you need to subtract this from the 30, whatever is here, to get that. On the other side, same thing. You take the 25 here, you subtract the 10, and you're left with 15 students or homes that only had a computer. And now let's do the math. You're writing this down. Go ahead and write it down. 20 and 15 is, sorry, 20 and 10 is 30, plus 15 is 45, plus 5 is 50. So now it actually all adds up to your universal. You've double checked, you've gotten that right. And so if you get that and that, right? Once you figure that out, you can move outwards and figure out the rest, okay? So let's see what else they're asking us for, because now that this is filled in, you can answer anything they ask you, okay? So I'm gonna go up here to B. How many students were able to access both a tablet and a computer? Show your work. I just did. So basically, when I did all of this, I answered B. So that's the longest piece, perhaps, for you. What about C? How many students only had a tablet available? You are allowed to, right? Number of students that only had a tablet, but not, let me just check here, but not a computer would be 20, right? I also want you to have the notation that goes with that sentence out there. D, how many students only had a computer? So the number of students, or I mixed up students and homes, I know, but that's okay. Computers, but not a tablet, and it's like a backwards slash, okay? I go over here and it's the 15. 15. Okay. And E is asking how many students had at least a computer or a tablet, not a table, sorry, available. So that is just your or, right? So this is basically asking, I'm going to do that right where E is. They're asking what's the number of elements that are in T or C, right? The emphasis here is on the or, right? Or. Okay? And that would be just this, right? Both of these circles all added. So 20 plus 10 plus 15, which is 45, right? Or you could have just said universal minus the outliers to get the same answer, okay? So I'm going to ask you to, at this point, I want to just maybe prepare you for the work that I'm going to assign. So, Mr. Dirksen, what if they gave me this, right? What if they gave me this and the question might have something that says only, like the question could have said at the very beginning here, 30 students only had a tablet, only had a tablet. When they say that, when they give you that information, that number actually goes right in here, not at the top. Because the word only tells you that it's just this section here. Or only a computer, they would actually be referring to this section here. Okay, so we're gonna have to do a couple more, but I will already assign to you and we'll go from there. What's the time? 30 minutes already on the video. So what I will do is I will assign, in the meantime, page, this is in the textbook, okay? Page 172, question 3, 4 to 7, sorry, 4 to 16. I'm asking to omit question 14, okay? So try your best. I will do more on Monday, but there will be a small AC for you to do. And it's basically going to be something like the question, the word problem I just did, and then some basic ones from the previous section as well, pages 13 and 14 already as well. All right. Thank you. Have a good one.